the worst recording of a SAC ever made, but it could be the only one. So we'll talk through this SAC. This is from a few years ago now. A couple of parts to it, but we'll hook into it and see what we come up with. So the first part, types of variables. So I've got a whole lot of cars and the distances that they've travelled in that time. So we've got the age, and what type of variable is the age? We've decided that's going to be a categorical, because we're 5, 10, 15 years. Alright. Next bit, what type of variable is kilometres travelled? Well, that's pretty obvious now. It's going to be numerical. Alright, the key statistics for 5-year-old cars have already been done. Use your calculator or another method to complete the table below. I reckon the best way is going to be using a calculator. Don't do another method with this one. Obviously you're going to have to get all these in order and then work out the mean, median and so on with those. So this is just a matter of putting them into the calculator and getting all those values sorted out. So remember, there are values, alright, so 170, 100, 250, 130 for the 10 years old. Menu 411, it's a good shortcut. That is in the A list. Super, we'll tab through, result column B, terrific. So there are the values, there's the mean. And keep rolling down, standard deviation, minimum, lower quartile, median, upper quartile, maximum. Alright, we can do that for the 15 years as well. Menu 411, that's okay, it's in list D. Terrific, E, tab, 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 tab. Sorted, and there we go, those ones there. Alright, so that shouldn't be that tricky, I'm hoping. Alright, onwards. So the range and the interquartile range. Remember, the range doesn't show up on the calculator there. We're going to have to work out the range, the maximum, take away the minimum. So I'll end up with 200 with that one, I'm hoping. And with this one here, the range is going to be 350. 400 take away 50. Super interquartile range, the difference between the upper and the lower quartile. So that's going to be 110 for the 10-year-old cars, and upper and lower quartile for the 15-year-old cars, it's going to be 120. Okay, terrific. So next bit, we need to put a box plot to help compare the 3 different car ages. Okay, so again, you can confirm this on your calculator if you want. Alright, there are the dots there. Let's talk about how, well, that's the scatter plot, or the box plot there. Let's talk about how we get to that. So we've got the cars there, and the years, the 10-year-old ones there, and the 15 there. Control I, our data and statistics. Down the bottom, we'll have, what will we have? We'll have the cars, okay, and then the years. Never get tired of watching dots move around. Menu, plot type, it's a box plot. Bingo bango, there we go. Shouldn't be any dramas with that. We can copy that in. So, the 10-year-olds, minimum of 100. There we go. Little line. Upper quartile 140. Big fat line. Median 195. There we go again. Upper quartile 250. And max 300. Okay, now all the bits. There's our tails. Terrific. Okay, and if you remember, that 15-year-old one's got that outlier there, and that 50, so someone's obviously bought a car for 15 years, and it's been the grandmother that's sort of driven it to church on the Sunday, literally. So So there's that outlier there. So the next smallest is going to be 150. Alright, so back up to these ones up here. So we take that 50 out, put that as our outlier. The next smallest is going to be 150, so that's where our box plot's going to start. There we go there. Upper quartile 240. There we go. Median 320. Terrific. Upper quartile 360. Max 400. There we go. Well, we didn't quite get that 400 in there. There it is. Righto. There's our tails, boxes. Hopefully we've been doing this with a ruler, so it makes sense. Terrific. Alright. So there's our box plots for the first page. Alright, we start now to get into some issues about describing these. So detailed description of the 10-year-old distribution in terms of shape, center and spread. So a couple of things you need to think about here. Shape, whether it's going to be skewed, positive, negative or approximately symmetrical. Center is going to be our median value. And spread's going to be an interesting one. If we've only got the box plot of our 10-year-olds, like here, we're only going to use the interquartile range as a measure of spread. But seeing as though we've worked it out here as our standard deviation, we can mention that as well. Alright, so 3 marks, shape, center and spread. If you have a look at it, I reckon it's probably going to be pretty symmetrical. So that's the first thing. 10-year distribution. Approximately symmetrical. Alright, super. What's the next bit? The center. So where's the median at? Remember back, the median's going to be 195. And that's 1,000 kilometers. Alright, and the spread. So the interquartile range was going to be 110. Alright, and a standard deviation, because we can mention that because we worked it out, of 63.6. Okay, so remember back, if we're only talking about, if we've only got the box plots, we're going to use spread as the interquartile range, but seeing as though we've worked that out on that table, remember, we can use the standard deviation too. Okay, so if the question asks, use the box plot and give a detailed description, okay, we'd have to use the interquartile range. Okay, next bit, this is a whopper. Compare the 5 and 15-year-old distributions including relevant values. Okay, so we're going to need, it's a 4 question mark all the way down the bottom, so we're probably going to need at least 4 things. There's going to be a few things that we can have. I'm going to pause it just for a quick second and write these out, because that's pretty boring just to watch me write, and then we'll talk through what they could be. Okay, onwards. There's quite a few things here, right? So it's like I said, a 4 question mark. So there's a few things you could say. So have a look back at the box plots. Both have got outliers. 5-year-old car at 340,000. So someone's really thrashed it after 5 years. And the 15-year-old car, remember, owned by the grandmother, going to church on Sundays. It was only 50,000. The shape of them, both different shapes. 5 years is positively skewed, 15 is negatively skewed. Centre, as well as would expect, they're going to be a little bit different. The 5-year median at 100,000, while the 15 years median at 320,000. Now remember, with box plots, to use the median, not the mean. And then we talk about the spread as well. Okay, remember, if we only had the box plots to compare, we'd talk about the interquartile range. So the interquartile range at the 15 years is 120,000 compared to only 100,000 for the 5-year-old. But because we've already worked out the standard deviation, and that was part of the question too, we'll use that as well. So the standard deviation for the 5 years is 92.4, and the 15 years is 111.1 thousand Ks. Okay, so both of these, the interquartile range and the standard deviation, suggest that there's less variation in the 5 years, in the kilometres travelled of the 5-year-old cars. Okay, so that's a whopping question, 4 marks. So should probably try and have 4 things. All right, let's move on. Okay, here we go. Part B. This is the real teeth of the scatter plots and a regression analysis. So we've got the vehicles, how old they are, and what price we'd expect to pay for them. Okay, so the independent variable and the dependent variable. All right, if you're really struggling, think about this. Remember, okay, so that one causes a change in the other. Okay, same both ways. So does age cause a change in the price, or does price cause a change in the age? Okay, pretty obviously you would think that the age causes a change in the price. So we've got the age is the independent variable. I'm also going to put a little X there to remind us that that goes along the X-axis. The price is the dependent variable. I'm going to put a Y there. Hey, if you're really stuck, have a look at the second part of the question. Okay, we've got the price along the Y-axis, so that suggests that that's the dependent variable. Okay, and the age along the X-axis. Alright, so there's 4 points missing. Okay, so 3 years, 5 years, 10 years and 15 years that we've got to put on this. Okay, so that's just a matter of looking back at the numbers up here and putting them in accurately. So 3 years we expect to pay 25,000, so that's going to go right on that point there. Easy. 5 years, 1,500, so it's going to be up there. What are we up to now? 10 years, 5 grand, and 15, 27, so a little bit less than half, so all the way down the bottom. Alright, insert a least squares regression line, insert, so we're going to need to draw this one, right? I haven't got a ruler, so I'm going to pause it again for a quick sec and try and rummage up a ruler. And we'll also, while I'm doing that, make sure you put all those values into the calculator so that we can actually have a go at them. Call them age and price, because we're going to need to do some transformations later, I'm tipping. Revise something, but I've been able to put those ages and prices in. Okay, so there they all are. Call them age and price. Okay, age, X-axis, price, Y, remember. Okay, there they all are. We need to work out what this equation might be. Alright, so menu for stats, because that's what we're doing. We want to do a calculation and we want to work out the linear regression. Alright, so 414 is a really good one. X list, remember, that was our age. So we can call it either A or we can call it age. Super, there it is. And the Y list is going to be price. There we go. Alright, tab through. First result, column C, super, so it's going to come up in the C column. Alright, and here are all the values. So we've got the equation there, y-intercept of 30,236.1, probably 0.11 here if you look down the bottom if we do this rounding properly. Gradient at negative 2,308.46. Then we've got strength values here, coefficient determinations, and Pearson's product coefficient. Alright, and I reckon all those things we're going to need in a sec. So let's see if we can get that stuff written down. So the least squares equation, y equals 30,236.11, negative gradient, remember, 2,308.46 times by x. Okay, We actually haven't been asked to work out the equation in terms of the variables, so that's going to be the next bit. Alright, r squared, there it is there, 0.7320. Remember to round this one, okay? 0.19, that 5 is going to make that 19 up to a 0, so we've got 7.7320. Okay, so the terms of the variables used. So the y-axis, that was calling price, right? So that bit done for us. Okay, so 30,236.11 take 2,308.46 times by age in years. Now, we've only got 1 mark for this one here because we actually haven't sketched it on yet. So back up to the scatter plot, we need 2 points. I reckon a good point is going to be the y-intercept. Alright, so a bit above 30,000. And the gradient's going down 2.5. Alright, pretty close to 2,500. So if we go 2 years across, we'll be going down about 5. So that's going to be about there, and we'll take it up just a wee bit because it's not quite that. Now I've improvised here. I've got Wonder Walks of the Grampians National Park. It's the closest as I could find. Join up those 2 points. Alright, and that's going to be our equation. Terrific. There it goes. Alright, so it's not great, but it's pretty okay. Alright, back down the bottom here. Question 3. State the gradient and the y-intercept. Okay, we've spoken about it a bit. There's our gradient, there's our y-intercept, and comment on each in terms of the variables. So the negative gradient of 2,308.46, so that means for each year that the car gets old, the price is going to go down $2,308. Okay? For each year, value of car decreases by 2,308.46. Okay, negative gradient. Y-intercept, there we go, we'll just retrieve that, 30,236.11. So that suggests that a car that's 0 years old, so let's call it a new car. A new car should cost $30,236.11. Alright, sorted. So we've got both the values, got an explanation for each. There's our 3 marks. Onwards. Calculate the correlation coefficient. Glad I'm not drunk or hungover at the moment. Correlation coefficient. Alright, and comment on the strength and the assumed linear relationship. So, back to our table, there it is there. Alright, negative 8.5554. Alright, it's a negative. So, R equals negative 0.8555. Alright, that last 4 is not going to change it at all without rounding. Let's leave it as that. So remember, direction and strength. So we've got a negative relationship, and it's probably going to be pretty strong because it's going to be greater than that 0.75. Alright, so negative, strong relationship between age and price. Okay. Next bits. Use your model. So that's going to be probably on the equation, right? The price of a car that's 6 years old. So this is the easy one. So all we need to do is come back to our formula. There it is there. Alright, and we're just going to change that age to 6. So price equals 30,236.11, take 2,306.46 times by 6 for the age. Alright, let's see how we go. I reckon I've got a calculator somewhere here. Oh, there's those box plots. That's not that interesting. Here we go. Alright, 30,236.11 take 2,306.46 times by 6. Alright, so for a new card, there we go. 16,397.4. 16,397.4. Alright, terrific. The age of a car that costs $2,000. So we're looking down the bottom end here, I reckon. This is going to be a solve. Alright, so this time we've got 2,000 here equals 30,236.11 take 2,306.46 times by x. Alright, put that in the solve. If you haven't worked out the solve function yet, it's a ripper. Menu 3, 1, there it is. 2,000 equals, I'm going to get a bit cheeky and use a bit of this. Control copy, Control V. Alright, I'm just going to get rid of that x, put a comma, x, there we go, 12.24 years. So age, we'll leave it here, 12.24 equals age. Alright, onwards. Complete the following table of residuals. Here we go, big words now. Alright, residuals, it's going to be the difference of the price and the predicted. Okay, so what it actually is to what it is on the equation. Alright, so I've got all these values here. Let me talk you through how I got them. Alright, I'm going to use the calculator. It's going to be really helpful. Alright, so there's the ages and the prices. If you type in age at the top, it's going to remember from a few pages ago that we've got all these. There's the prices. Super. So the predicted is going to be our equation. So there it is there. We can put that equation into the box, alright, to work out what the predicted value is going to be. So let's do that. So predicted equals 30,236.11 take 2,306.46 times by age. We need to call it back to here, right? So we'll type in age. Okay, there are all those values. Okay, should get those. Alright, we're also going to use this one to work out what the residual is going to be. So remember the residual, yeah man, this is really awful with this, you know, screening here, but hopefully you're getting all this. The residual is going to be the difference between the actual price and the predicted price. So let's just put that in. Okay, so there's our two variables. So equals price, P-R-I-C-E. Whoa, got a bit out of control there. There we go. Price. Take away predict, P-R-E-D-I-C-T-E-D. Okay, so there they all are there. Alright. The calculator can do wonders, alright? Use it well and use it wisely and you should go okay. Let's see if we can just get a better picture of that one there. That might work, that's probably worse. Oh, there's the phone message. Great times. Action. Okay? So use this properly, it's going to make life a lot easier. Alright, let's come to working out what the residual plot's going to be. Okay, so the residual plot's just going to plot all those residual values. So the first one we can confirm that with the calculator in a sec, but it's probably not worth it if we actually have got faith. Alright, the first one at 1 year was going to be 12,000, so that's going to be pretty close to there. Second one's going to be 6,300. Third one, 1,600. 4, we get into the negatives now, negative 4,000. 5, 3,600, so a wee bit up. 6, 6, 3. 7, negative 10,000. 8, negative 2,700. 9, negative 5,700. 10, negative 2,100. We're right in the 10s there, right in the guts of it. 11s, we go back to positives. Positive 450, so it's going to be right down the bottom there. 12, positive 2,000. 13, 5,300, so a bit above there. 4, oh, hang on, whoa, remember, no 13, that's the second time this one's caught me out. I'm going to put a line through that. Okay, 14, 5,300. 15, 7,900. Now, if this ever happens on an exam, okay, put a line through it, even make a note, not a point. Okay, and then that should be ignored. Alright, so I've completed the residual plot. Comment on the suitability for your model. So remember, the residual plot shows how linear, if there's a linear relationship. Okay, if there is, we'd expect all these plots to be all over the shop. Okay, but we've certainly got a pattern here. Alright, so there is a pattern on the residual plot that shows that there is going to be a value, or sorry, a model that's going to be better. Alright, or RES, get that right. So the residual plot shows a pattern. So linear relationship, not the best model. Transformations should be completed. Okay. Alright, back to our scatter plot to work out what transformations there are. Okay, this is the worst quarter for the circle of transformation. Alright, so we're looking bottom left hand corner. There's going to be 4 of them. Alright, so one of the 4 is going to be a log of y, the log of the price. One of them is going to be the reciprocal of the price. One of them is going to be the log of the age. The other one's going to be the reciprocal of the age. Okay, so we need to select an appropriate transformation to find the best model and work out why it's the best model. So that's where these ones come in. Okay, now I'll talk us through one of these ones. We'll do the log price. Then I'll get you to have a swing, or you should be able to have a go at the others based on that, and then we'll come back and we'll talk about how this is best. Alright, back to the calculator that you may or may not see. Okay, across a couple, hopefully we've got an age. You can't really see it, so I'm going to explain. But the age down this one, and we've called this one at the top, we've called this log price. Alright, oh there we go, light works. Okay, so there's our formula bar. We're going to put in, remember, we've called this variable price, so back a few pages ago, so it should remember. So we're going to go equals log price. We want to go log, so control 10x, 10 down there, and that needs to be price, P-R-I-C-E. Okay, there are those values. Good news, we don't have to sketch this or anything like that. We want to do that regression menu for one linear regression, number 4. Okay, the X list. I'm going to keep it simple and call it in that column A. Alright, and the B list, well, the Y list is going to be in B. Okay, you can call it age and you can call it L price. Okay, log price, and then that's still going to be the same thing. But if you've got it in the first couple, that's probably not an awful idea. Alright, B, there are the brackets, tab, 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 tab. First one's C, there we go, there's our equation. Okay, so y-intercept of 4.55, gradient of negative 0.0818, and here are our values for r and r squared. Okay, so we'll jot those in, then we'll have a go at doing those other three, and we'll come back and work out which is going to be the best one. Now I've got all of these set up on a different page. Alright, so remember, Control I for a new page. As we go across. Alright, there's the next one, age and the residual of the price, so that's the 1 over. Then we get into the log age, and the price is still there. And then the rage, the reciprocal of the age and the price. Okay, so all of those, go to the formula, menu 414. We should be able to work out that equation, and there's correlation coefficient and the coefficient of determination really easily from there. Alright, so I'll pause this for a sec, we'll work out the equations, and then we'll come back and we'll work out which is going to be the best model. Alright, so hopefully we're back again. We've got all the values, so you've been able to work it out, put in those equations. I want to talk through this one here, the reciprocal of the price. We've got negative 1.6684 times by 10 to the power of negative 5. Okay, so when you put that into the equation or into the calculator, you can see we've got some really small numbers. Alright, down the bottom, have a look, we've got 2.32169, and then e to the power of negative 5. So that e to the power of negative 5 is saying 10, or times by 10 to the power of negative 5. So we're going to move that decimal point 1, 2, 3, 4, 5 places that way. Okay, so that's the way it's written there. But for those few decimal places that we need, okay, it's not a bad habit to get into writing it like that. Okay, so there we go. So there's all the equations. Now, a couple of things to think about as well, and remember, when we put the equation in, you need to actually have what transformation you've done. Okay, so with log x, we've done the log of age. With the reciprocal of x, we've got the price equaling all of that times by the reciprocal of the age. Alright, so looking through here, I'll give you a sec to have a think about which is the best model. Alright, a couple of ways you can do it. Alright, it's going to be this one here, log of x, because we've got the biggest coefficient of determination and the biggest correlation coefficient. Okay, so both of those are larger than any other of these r and r squared values. Alright, so that's the last bit, explaining why. So, log age, the most appropriate. Transformation, because it has the greatest coefficient of determination and correlation coefficient. Okay, either one of those would be ace. Alright, so there we go, there's a practice sack. Hope it wasn't too awful to wade our way through this. Hopefully you got something out of it, and good luck with it, and we will hopefully get some good results with the sack.